I'd like to introduce Paul Wallish and his colleague Paul W., both from CTEP.
Hello.
Our friends from the Workforce Board, Brenda and hi. Also from PHCC, we've got Margaret, hi. And then I think we have got Dave, when I find him, he's standing up at the back from River Ridge School, and a couple of the interns are with Dave in the engineering program at River Ridge. So we'd like to thank you for all the support that you've given us, both the support and the investment that has gone into this program. We feel it's been a really great success. I also want to take the opportunity to thank Pharmaworks employees as well, because the Pharmaworks employees have made this work, and there's been a lot of dedication. And the other guy that's taken the weight off my shoulders and has really made it work is Dan Albright. So I was sitting in Peter's office, and for those of you that know Peter, Peter's a visionary. He's had a passion for training for many years. It was his involvement initially with engineering. And I'm sorry that he's not here today. I've been on the phone with him half the morning. He's really desperate to be here. We're filming it for Peter. And he's been the visionary, and he's been the owner or part owner of this business that has been really committed to making this work. So I was sitting in Peter's office about early May time, and we've run a program a couple of years, but it's not been as organized as we would have liked. I think we've provided the students with some great experience. And last year, as we acquired this building in the summer of last year, and we went about refurbishing it, it was a real big help as well. And I think the interns that were with us last year learnt a lot as we were preparing this building for refurbishment. But we had decided that this year it needed to be more structured. We needed to have a program, and we wanted to rotate the interns through the business side of the operation as well as on the shop floor as well. But at the same time, we wanted to also give them some education. So we're sitting there, and Peter and myself are trying to hammer out a program, and the receptionist, Joni, knocked on Peter's door and said, there's a guy in reception who he says he's looking for a training job. He used to train apprentices. He's retired, but he's looking for some work. Shall I ask him to come in? Well, that was Dan. And 3 hours later he left us, and 2 days later we made a phone call, and he ended up joining us about 4 weeks before we started the program, and helped us develop it. And what we actually kicked off on the 10th of June was a result of what we'd initially prepared and what Dan took on when he joined us. So you ask yourselves, why do we want to do this? What is the benefit from doing this? Why is it we want to put the effort in when, as a company, we're really busy? We've been growing rapidly as a company. We've got a full order book at the moment. We're working a lot of overtime. Well, there's a few reasons. One, look around this workforce, and there's quite a bit of grey hair. And in some cases, there are some polished crowns as well. We've got an aging workforce. The median age in this shop is 55, which means, if everybody wants to retire by age 65, everybody in this shop will be replaced in the next 10 years. So that's one reason. You go across the road, and the age situation is very similar. We have got a lack of skilled, experienced people coming through and applying for jobs. That's not to say we don't get plenty of people applying for jobs, but finding people that have got the right skill level, have got the right experience to be able to come in and make a contribution fairly quickly and not have to go through a lengthy training program. I was just looking at our vacancies before I came across here this morning. We have got 9 positions open at the moment, and half of those positions have been open for more than 6 months. And that's not because we haven't been trying. That's because we struggle to find the people with the right skills and the right experience. The other thing is, when we've recruited people, and particularly in engineering, we have recruited graduates, youngsters that have not been out of college too long, and they have got great computer skills. They're whizzes on the computer, but in terms of their practical experience, it's very limited. And I don't know about you, but I don't think you can be a good engineer unless you understand the practical side. So it's very, very important. And I see a couple of our assemblers at the back are doing this. Those are the guys that have to put together some of those designs which didn't have a practical perspective. So one thing that we've started to do as new engineers join us, they spend time on the shop floor initially. And that's something that we've introduced fairly recently, but it's something which everybody wins as a result, and it's giving them good experience before they start putting out those designs onto the shop. The other thing is, which we have we've got quite involved in through CTEF, through the school system, the colleges, and there's been a general push to emulate the German system, the German training apprenticeship system. You know, it's proven its worth for Germany. You know, there's still a high percentage of kids that are in school that are getting vocational training, and all their engineers, they all have had practical experience. And so it's important that we get youngsters involved in industry as early as possible. It's important that parents understand the opportunities that there are in industry. You know, it's no longer a dirty industry. You know, this is a fairly clean shop. There's some highly sophisticated equipment across here. We build highly sophisticated equipment, automated equipment. So, you know, there's wonderful opportunities in engineering, within manufacturing. You know, we want parents to understand what those opportunities are, as well as the young adults themselves who are interested in pursuing a career. So, you know, we're trying to achieve the objectives of the company, but we're only going to do it if we work hand in hand with education, with the schools, with the colleges, and so on and so forth. And, you know, there's been a lot of effort with Paul in particular through CTEF, trying to take this in the right direction. I think there were a lot of roadblocks in the early days. There was a lot of frustration. You know, we would have liked to have taken the politics out of it. You know, every time you turned a corner, there was another 3 people that had an interest that wanted to take it in a different direction. But I think, you know, full marks, Paul, you've stuck at it, and, you know, we've made real progress. And I feel that 5 years down the road, and I hope others feel as well, that, you know, we are moving in the right direction. For me, a gauge is that we're seeing more and more youngsters, particularly out of the schools that have got engineering programs, i.e. Eastlake, River Ridge. They want a career in manufacturing, in engineering, and it's a route that is important, and it's important that we as industry give individuals that opportunity that is required. So I'm not going to say a whole lot more, because this afternoon is really about the interns and not me or the company. So at this point, I'm going to hand over to the. I think Dan's going to speak a little bit first, so I will let Dan introduce the interns.
Thank you. I'd personally like to thank my partner over here, Trevor, even though he doesn't speak really good English. He's been a person that I've been running to, and Peter also, but Peter has had his share of time on the road recently, and so Trevor has kind of picked up the bull by the horn, so to speak, to get us to this particular point. I just wanted to take a little bit of time to explain how the program was laid out. I mean, our interns will tell you how they went through the program, and they have a very valuable story to tell, so I'm not going to spend a lot of time talking about it, but a little bit of background is worthwhile. My background, I've got about 25 years as a training consultant with a couple of different companies. So what Trevor said is true. I was retired for a while and I had a need to get out into the workforce again. They don't tell you how to prepare for retirement, but after about 5 years, you're tired of talking back and forth between the wife and you got to get out and socialize in a different environment. Thank you. Anyway, the program was put together as a combination of classroom and online stuff and OJT that we call shadowing. And we wrestled with a couple of different things. When I got here, both Peter and Trevor had some very defined ideas about what they would like to see in the program, and based on what they had done last year and based on what they thought might be appropriate to do, and that's to provide some background on safety so that once we allowed them to shadow out here in the machine shop and across the street in the assembly building, that they would be prepared for that. They would have some knowledge about how to work safely in the workplace. So we worked out some courses that we brought in PHCC actually to teach for us, safety awareness courses that we did. We decided on doing it in the beginning of the program rather than trying to interlace it throughout the program. We believe that if we gave them that training, even though it was probably a lot of classroom training up front, it would prepare them once we started to do the shadowing. Okay. The other thing that we did was we established different areas of the shadowing group. So we approached the managers, the area managers, and we approached people that wound up being their mentors when they were actually out there doing their jobs or learning how to do their jobs. And some of those mentors and some of those managers are here today, and I thank you for coming over. You got some valuable input. These guys, they like the fact that you take your time to show them and explain to them things that they will take with them from this area. When you hear their story, you're going to get the gist that it was because of you that they learned so much. So we front-end loaded the safety courses, and then we established weekly schedules that we put out for both the interns here and for the people that were guiding them through the areas, the different areas in the facility. And then my job after we did the training and stuff like that was pretty much to follow up and to adjust for the ebbs and flows of business. One of the things we've done, kind of a tedious task, but that's what I was tasked with doing. And so when they went out and they found out that even though they were scheduled to work in a specific area, there might not have been any work in that area, they would come back to me, or I would find out that they needed work in another area, and I would try to find some additional place to put them. We actually had about 8 different areas that within the organization that were utilized to allow these interns to work. And they are in assembly, in the machine shop, in tooling assembly, in tooling engineering, in controls, mechanical engineering, in receipt inspection, and in purchasing. Now they're going to mention in their presentations about these areas that they work. So you just have some idea of the fact that we tried to give them an overall view of all of the things necessary to actually put out our end product at this company. Okay. Another thing that we had working for us was we had talked, and actually they were talking about trying to do a class project from, I guess, the end of the last time when they got together last year when they had the interns in. And one of the things that was decided was we would put together an element of the machinery that is being produced at this company. And the element that we chose to do sits here in front of you that they'll talk about, and that's an outfeed conveyor. These outfeed conveyors are used as the last element, the last area that the product goes through on our thermoformers. So one of the things then that we're going to do in this presentation is to allow the teams. I broke them apart into two teams. There's team 1 and team 2, and we're going to allow each team to come up and explain to you all the pitfalls and how they put these pieces of equipment together. By the way, these pieces of equipment will be put on the shelf and will be utilized in actual pieces of equipment that are sold in the future. So, I mean, that gave them some incentive to do the job and to do the job the right way. And they did a very good job. The other thing that we would like them to do, and the reason why you're all gathered here, is we would like to hear their feedback on how the program was. I mean, after all, the program was put together for our needs, but the program is also put together for an intern's needs. What can they take away from this program? And we'd like to know good, bad, and indifferent things that we can do to improve the program for next year. This being the pilot year, we're trying to get all that down and smooth out the rough spots and try to make it even better next year. Okay. So without further ado, what I'd like to do is ask each and every one of them, and I guess I can go around the table and introduce those people. As I call your name, why don't you just stand up and say hello, and then you can, when you get to your personal presentation, then give them a little bit of background as to who you are. Okay. Starting in the front here, we have Jacob Dixon. Jacob, would you just acknowledge the crowd out? Okay.
Yes, I'm Jacob Dixon. I'm one of the interns here. I heard about the program actually about 4 months ago. Mr. Kuczynski took me around a quick little tour of the factory, and I was really interested from the very beginning. You know, I got to see all the different machines, different departments. It was real cool, and you got me hooked right off the bat. And I'm excited to start here June 10th. So it's been a great experience so far. Or, I guess that's now.
Sitting behind Jacob.
I really enjoyed my time here.
Next around the table is Sarah Sharp.
I'm Sarah Sharp. I actually heard about this internship through my mom who works here. And it's just been a great experience. I've loved my time here. It's been great.
Around the table is Hannah Grant.
Hello, I'm Hannah Grant. I heard about this internship from Cameron, but we took a tour of my engineering academy with Mr. Dave Hoffman, and it's great.
Next in line is Matt Brower.
Hi, I'm Matt Brower. My dad's actually one of the owners here, so that's how I heard about the internship. And I was out here, you know, in early years planting trees and pressure washing decks, and it was really neat to actually get inside the company and learn some hands-on.
And last but not least is Amber D. Polo.
Hi, I'm Amber DePaulo. I heard about this through the engineering academy at Mexico Bridge, and after the tour, I really was interested here, and basically, through the robotics program that they have here, I weaseled my way in, and I started here. I've been here since January, so I started before the program was actually here. I've loved it so far, and can't wait to continue on.
Okay. Proceed on. We're going to get started with the team presentations. And I know you're going to have questions, but I think for just their sake, let them get through their presentations first, and then we'll open it up to questions and answers everywhere. So, you know, think about the questions that you might have for them, but it's a little distracting to stop them and ask that question, and then they got to get back into their presentation to figure out where they're headed. Okay? Thank you.
Amber, this is Hannah, and that's Matt. So our group project was to do this outfeed conveyor, which, as Dan said, will be used on an actual machine later on when they decide to put it all together. It all started out when Dan told us that we were going to be doing a project together, and we drew out a pads of who was going to be in what group. So after that, Dana gave us the BOM, which is the bill of materials, and also the exploded view, which is also there on the table. And after that, Trevor had sat us down and showed us the system that they use here for the part numbers, and also how to go through the BOM and the exploded view and understanding what it is and exactly what parts we're looking for. After that, we got to see through one of our CNC programmers, Matt. He showed us how to actually program the CNC machines for our base plate, that part. From that, Dan had us sit down and decide exactly from the exploded view and the BOM how we would start it, which part would be our starting point, and we decided obviously with the base plate because everything is off of it. After that, Dana told us that the kit was completed, so once we got that, we got to check off all the parts and see what was there off of the exploded view and the BOM. And once we checked them all off, we got to go and see what was missing, which we realized were Kanban parts. And Kanban is a system that we have adopted here at Pharmaworks, which is a visual visual inventory upkeep system. And basically what it is that when there's a bucket of hardware, say nuts, bolts, screws, and when it starts to look like it's low, you check the Kanban cards, which tells you the minimum and the maximum numbers that we have that are supposed to be in that bin. And when it looks like it's running low, you just stick it in the green bins, usually at the ends of the stations. And that way they know at the end of the day if they pick them up and that they need to be sent to purchasing and be replenished.
That we just teach you guys on the
guys.
So after that, we got all of our parts that we needed and realized we were still missing one more thing, which was our drive shaft. Dana told us that that was still coming in, so it was coming in, we had to wait.
And from there, we got some helpful hints from a few of the employees here, which Jesse, which is right back there in the back, he showed us a guideline of pretty much what we were doing because he had already assembled multiple of the conveyors. So we were using his as a guideline pretty much. And he warned us about the gear gap, which you can't see because cover, but it's pretty much a metal gear that is put onto the plate, and we don't want the metal on metal to rub, so we had to leave about, I'd say, a millimeter gap. And Clayton told us that on the plate, the plate, he warned us about the noise and friction that it would cause when running, and he fixed it with Teflon tape, which he put one side around both sides of the plate and then one on just the top, which unfortunately didn't work with ours, but he had a higher tolerance with his and ours was not, so we had some troubleshooting to do. But we started to build off the base plate as we had originally planned. Yes, thank you. And we pretty much learned that we had to use the grease and put it on the tip of the bolts before we put the screws in. Ralph taught us how to press bearings into the rollers, which are on the conveyor belt. And we were not to tighten any of the bolts all the way until the belt and everything was aligned. And we pretty much had to do trial and error to decide what type of screw to use, whether it be button head, short head, the finished screw. And we used lock washers and flat washers on some of the screws, which pretty much we learned when and where to use it.
All right, so once we had the base plate and the rollers in, it's time to put the belt in and the belt plate, which is under this. So we already had the rollers attached to one side of the side plate, and we couldn't put the belt on until we attached it to the other end. So, but the issue that she was talking about earlier with the base plate, this belt plate, Clayton had originally put tape on the edges of it, and this was used to reduce the rattle and to give it a tighter fit, because there are slots inside these side plates where this plate in here is supposed to slide into. So we had to put tape on there to make it a little bit snugger. And so we put tape on ours, and we were trying to put it in there, and it wouldn't go. And it wouldn't fit, and it wouldn't fit. We couldn't tighten it down, so we were like, crap. So then we're like, all right, let's go get Bobby. So we went and got Bobby, and we're like, Bobby, we have this problem. So we talked to him for a while, and he told us to take the tape off. So we're taking the tape off, and we take it off one side, we try to put it back together, it still doesn't work. So we take it apart again, take both sides of the tape off, put it together, and finally it goes together. So then we have the belt on, and we have everything connected, and we're supposed to attach a retain ring to this drive shaft right here, so everything stays tight and snug. And we had a problem where we couldn't get this retaining ring, this black ring right here, we couldn't get it to fit into the groove on the drive shaft. And we were trying to persuasively tap it in there, and it wasn't working. Once again, we went to Bobby for help, and we realized that this groove on the drive shaft was about 1 millimeter back too far. So there was no way we were going to get this ring in there. So what we did, we had to take one of the shims off, which is it's like a washer. It goes between the drive shaft and this retaining ring. So once we took that off, we had enough room, and we were able to put everything together. And we tightened everything down, polished it up, and we actually were able to take these to the Bauer Expo, which is similar to what we're doing here, where some of the interns got to talk about their programs and what they did. And we were able to show these off, and we explained to them how they worked, and it was a really neat experience to present something we worked on for the company. And we came back here, we tested it, we aligned the belt, and everything worked great. And it was an awesome experience to be able to do this.
I think they did a good job. Now we have another explanation, another team. They had their own set of circumstances putting this thing together, so I want them to talk about their thing. So team 2 is Sarah, Nick, and Jacob. Thank you.
Alright, so as you just said, my name is Jacob Dixon, this is Nick Harmon and Sarah. The very first thing that our group started with was clearing the space for where we were going to work on this project. There's a spot over in the other warehouse, a little area that all the interns had their own area to work on the project. And so we were in charge of, at the very beginning, is clearing that area out, so we had a clean space to work, no one coming by and tripping and falling on what we were doing. So that was the very first thing we did, was clear out an area. From there on, that's right, one person.
From there on, our first project was to build a shelf, a metal shelf. It was more of a project, real companionship. Exactly what Mr. Albright said. What really happened was that we didn't have all our parts together yet. So, but it did actually build our friendship and more of a collaboration. So we worked better and efficiently when we actually got through a project.
And the next step in building this process was we got to see one of the parts that was manufactured here at the company. It's the main base plate where we started attaching everything from. It's up in that controls room up there. We got to observe one of the managers here who's working on the program for the base plate, and he showed us how the program worked, the tools that he had to show, what changed out on the CNC machine. So we actually got to see the program for the part, how it was made, and we got to go down to the CNC machine, see the part actually be manufactured, and see how that one specific part was made to this process.
So after that, the next thing we did was actually get all the parts together. And so some of the parts, as we said before, were made here, like the base plate. Some of them we got from outside vendors. Some of them we got from the stockroom over in the other building on the assembly floor. And some of them were from the Kanban stock, which they explained earlier.
Now, along the way, we got some advice at the very beginning. A couple of the things were that we needed to grease all of the screws. And I can remember quite a few times when we had already screwed in all the screws and then remembered, oh wait, we didn't grease them. We had to go back 4 or 5 times and re-grease a bunch of the screws, which was annoying, but now the thing works instead of, falling apart or being jam-packed together, so you could never take it apart for repairs. So that was a tip we had from a couple of the employees that came by, let us know to grease the screws. Another thing that we learned was how to use lock washers and flat washers. So the first thing you do is you put down the flat washer with the shiny side up, and then you put on the lock washer on top and make sure you push it down until it clicks, which we had trouble with later, as you guys heard from the earlier interns. And a couple other things we worked with.
A couple of other pieces of advice that we were given was that we should use how to press the bearings into the rollers for the conveyor belt. And the second thing was using the Teflon tape to prevent friction between the conveyor belt and the conveyor plate. However, we ran into problems with that later on in the assembly.
So as far as the construction process goes, as we said earlier, we started with the base plate, but I thought something that was cool about that is all the interns, we talked about it together before figuring out what we were going to do. I think the bill of materials was passed around earlier with that big spreadsheet, and there are quite a few different parts, a lot of different ways you could start on the project, and we unanimously decided, we're going to start on the base plate. And so that was one of those teamwork things that we had learned from building the shelf earlier. We had to figure out what are we going to start with, how are we going to decide who does what, and we all decided, we're going to start on the base plate and add on to it from there. But another thing that we decided we were going to do is, as we worked on the part, we were going to check mark off on the bill of materials and on the print what parts we had already used. That way we knew that we weren't supposed to be looking for that part number anymore, it had already been put on the machine.
So what we did after starting with the base plate is we attached the plate that holds the motor onto it. We attached the motor very loosely because we knew that later we would have to readjust it so that the belts would be tight. There's a belt attached to the motor that turns one of the rollers that in turn actually rotates the conveyor belt around. After that we attached one of the side plates, and then we mounted the rollers onto it. At the time, we were actually missing one of the rollers, and we couldn't really go any farther than that. And then when the actual roller that we were missing came in, it turns out that it was actually not manufactured just correctly. It was a little bit too big so that it wasn't fitting through the hole right. So we talked to Ralph, and he just sanded the end down a little bit so that it would fit through the hole, and it worked fine after that.
Yeah, that one part ended up giving us a lot of trouble. I think we had to go back to Ralph about 3 or 4 times for quite a few different issues for that one part, but we got it put together, so that was a good thing. Now, as far as the problem with the conveyor plate, the Teflon tape, as they said earlier, Matt went through the entire process. We ended up taking off and on the tape a couple of different times. So at first we thought, if we have tape on both sides, there's tape on the top side of the plate and on the bottom side of the plate. And we took out the plate, and just getting the plate to fit in those grooves, that's a hard thing to do. So you have to get all the rollers aligned, you have to get the plate stuck in there, and then we had the tape on top of it, and it would not want to fit into those grooves. So we decided, we'll try taking off one side of the tape, and that didn't work because it still didn't fit. So we had to go back and take off both sides of the tape, and we finally got it in, got it aligned, and we ended up removing the tape to correct the problem. But Bobby over there, he was the one that came over and let us know, that's probably what we end up needing to do to fix the problem. Because at first we didn't know if it was actually the tape that was the problem for why the side plates couldn't fit together. That was the problem, is these 2 side plates, they couldn't fit onto the base plate. And so we were trying to figure out, are some of the rollers too small? Are there washers in the way? And we had gone through a couple of different processes and figured, it's probably the tape that's causing too much space and too much friction for the plates to be able to fit together. After we finally got everything put together, we filed off some of the edges, made sure there were no sharp edges, and took it over to, I think it was John over in the electrical shop, and he showed us, we plugged it in and tried to see if it would work. And it worked. The motor ran, the pulley belt, it would move parts, but it wasn't completely aligned. The belt was a little bit off, and so we had to do a little bit of adjustments. I think where's the little area? Back here we had to tighten and release the sides of these so that the belt wasn't on there crooked, so it wouldn't fall off or rub against the edges. And as far as some personal learning experiences go, there were quite a few things we learned just from doing this project.
we had to think on our feet while we were doing this project, and one of the problems we ran into is how to determine what length screw we should use. In order to fix that problem, we ended up using small Allen wrenches and pushing that down the smaller holes and measuring how long they were with the calipers, so we can determine the length that we need.
Another thing we learned is, passed around earlier, there was a bag of screws and bushings. We had to figure out which type of screws to use in different type of holes, counter bores to button heads, and you know, that was something we learned from working in the factory, and we used that knowledge and experience and applied it to the build that we were doing here with the outfeed conveyor. One thing that I really learned from working on this project was how to work nicely with others. I tend to be a little bit more of a control freak, and I want to make sure I have everything planned. And working with other people, you know, it's definitely something different, and that was a good experience because no matter where you end up working, if it's in an engineering plant or out there, you know, crunching numbers for an accountant firm, you know, you're going to be working with other people. And from working with the shelf to working on this project, you know, everything we did as a team. The more we worked as a team, the more we learned about each other, and the you know, more organized we got. And it was real interesting seeing how well the team we became. And we'll let Nick finish out here.
I think we all had that same problem because we were all trying to be the head of the team, but we all had conflicting ideas. So it took a little while to get used to, but all in all, we all really enjoyed the project. And in the end, it all came together and it works. So,
Yeah.
thank you.
Yeah.
Thank you, guys. That was really good. So I guess this is, you know, Alpha's work together, this kind of a project. Actually, we didn't start the project, the assembly project, until week 4 of our apprenticeship program. So they had a sufficient amount of time to get out there, to actually get involved in the assembly area, to get involved over here in the machine shop, and to have some knowledge of what was going on before we actually sprung this one on them. They knew it was coming all along. Trevor had talked to him about it, I had talked to him about it, and we wanted something that allowed them to apply what they've learned up to that particular point and make them feel good about themselves. And as you heard, they learned a lot, not just about this. And you can see that there's a certain amount of precision that goes along with making something as small as a conveyor belt. So I think they did rather well, and they gained a lot from the project. Now we're going to start into the individual areas, the individual presentations. These will be a little bit different. They'll be short and concise and kind of structured about their own personal learning experiences and what they think is good, bad, or indifferent about a program such as this. This is the part that really, to us, is what we're looking for. We're really looking to see how can we make this better, how can we improve on it, you know, what do we need to change, and so we rely on their feedback.
When you said you were going to invite a few people, I didn't expect this many people.
We got more.
I'd like to start off by thanking Mr. Peter Buczynski. I mentioned earlier that if it weren't for him, I probably wouldn't be here. I met him by random chance when I was volunteering, and he brought me into the program. We had a couple of phone calls and a couple of weeks before the actual program started. Mostly everyone else had already been into the program. The second person I'd like to thank is Mr. Dan Albright for putting up with all of his interns in the last 6 or 7 weeks. With a smile on his face, as that fact. And lastly, I'd like to thank all of the mentors that we were able to help us on the way here, for sharing their knowledge and their experience with us and helping us on our way. This is something that, even with an engineering academy, that is not available to us in schools. The actual experience of working in a factory that is sending and shipping out parts that has a time stamp crunch. It's nothing like what we could achieve back at our high schools. And I didn't have an engineering academy. I went to Sun Lake High School, where I went to an engineering program. It was similar to it, but we primarily focused on working on SolidWorks. And that's the reason why I want to eventually become a mechanical engineer, eventually be designing parts for this company. It's a goal of mine. I just graduated from there this past year. So, one of the first departments I did go to here was mechanical engineering, actually. That was with Miss Kathy Sharp over there. And I'd like to thank her for that as well. It was a great experience. One of the few things I did there was putting together an assembly for one of the TF1 we're selling to a customer. I had to go onto the floor and examine the actual TF1 and be able to put it together on SolidWorks. So that was an experience. I was able to learn, exactly what stations we had, what they did, and why we were doing it. Later on, one of the fellows from tooling assembly, his name is Nick, also went into further detail, but it was also nice to have that prior experience with mechanical engineering. So thank you. One of the other departments I went to was machine shop 4. I was all the way back in the factory over there working on NC machines. First time I ever laid hands on one. However, at the beginning of the program, I was the only one that was 18 and allowed to touch it. So since then, though, we did have 2 birthdays. So Jacob had his birthday, he's now 18, and so did Matt. So they also got a chance to work back there. But one of the first things I did was create a block, and they were surprised I was able to properly make a block with a couple of cancers, which I didn't find too difficult with. I know Steve was a little over ecstatic. Thank you. Another department that I really did enjoy was inspection over here with Mr. Bob Vick. He was one of my mentors. He is interesting in one word. He claims that he has an ego, but I don't really see it. But he is a really great mentor. He does know a lot, so I guess he deserves to have an ego. I spent a few days here. I spent a few days here using calipers, pin gauges, and micrometers to measure parts and make sure they're aligned, which helped me to understand a little bit better how we did things here and the process of coming from the fabrication or from an outside vendor, go into inspection and go to the assembly shop floor on the other side. So I'd like to thank you again, Mr. When I originally applied for this internship, I thought that I was just here to get experience to put on my resume, and I got so much more than that out of it. This experience will last me for the rest of my life and take it wherever. But I actually do want to stay here, and I do want to work here, which is another good thing about this program. You get your feet in the door, and so everyone knows your face. So it lends it helps a little bit, when it comes to applying for the real job. So I'd like to thank Mr. Trevor Charlton again. I'd like to thank Ingo and Matt Stan. I'm sorry, I can't remember your name. And I'd like to thank all the other interns mentors I didn't mention, which was Jose, Ralph on the assembly shop floor, Dave in the back, Mike over in tooling assembly, and some of the people over in tooling engineering as well. Thank you.
Thanks, Nick. Next on the program, we have Ms. Amber DiPolo.
So coming from River Ridge High School, we had the engineering academy there. Mr. Hoffman, great teacher. I had known about Pharmaworks in my freshman year. We took a tour of this company and also Paul Aerospace. And after seeing Pharmaworks, I absolutely fell in love with it. I wanted to work here so bad. And obviously, wanting it so bad, I was so excited after it was over, the tour was over, because I wanted to go up and talk to Peter and be like, how old do you have to be to work here? I want to work here so bad. And obviously, not being a 16-year-old freshman, I had to wait. So I waited really late after one of the open houses that we had for our incoming freshmen, my last year, which was my junior year. And I waited so long to talk to Peter, and when I finally got a chance to talk to him, he was like, oh, well, we have a robotics program here that we sponsor. It's just a bunch of community kids, and some of them are from your school. Why don't you join? And I was the only girl on the team that year, the first girl for a while, and it was a great experience. But after that was all over, I kept pestering Peter to let me work here, and finally in January I got in. So once I was in, I was working part-time during the school year. I came in 2 to 3 days a week, and then during the summer I started working here full-time. And then they had told me that they were thinking of starting up an official program. And I remember getting a ride home from Peter one day, and he had asked me about how the program was now, like how I liked kind of being shuffled around, and if they were to do an actual program, what I think they should improve, and what would be good ideas. And this was still when the program was kind of up in the air. And I said that having someone devoted to the interns would be a fantastic idea, because Trevor always had his fingers and everywhere else in the company, and we're not always his main focus because he has so many other tasks to do, but he always made sure that we had something to do during the day. But not only that, but I mentioned that going around the company, even though I was here since January, I didn't go everywhere that I did in this program. So that was great, and that he took my advice on some of those. And also, I know they had talked about it before, because everything that I mentioned, Peter was like, yeah, we thought that was good too. But once the program had started, we had classes during the day. The morning classes were the MSSC safety classes, which were offered to us by PHCC, and Vince was our teacher. We went over stuff like OSHA standards and the hazard awareness and hazard communication, PPE and their programs, and PPE is personal protective equipment, fire safety and emergency response, electrical and tool safety, lotto safety, which is lockout, tagout, and we actually went through the procedures that we have here at Pharmaworks, not only the mechanical side, but also the electrical side, ergonomics and bloodborne pathogens. And in the afternoon, we went through PMMI University online training classes, which we went through intro to packaging, basic mechanical components, and basic electrical components. From there, we went through, got some other classes from some of the people who worked here, which Michael Ruth showed us basically the intro to engineering. He went through some of the stuff that we do here. And then Dan gave us an intro to PLCs, which are programmable logic controllers, which we actually use here. We use Allen Bradley, which are American made. Trevor also went over the Kanban system with us, and on the very first day he went through the whole company infrastructure after our tour, showing us from where the customer places their order to when we're getting it sent out to them. Later, after all of that all those lessons, I went through the shadow training, starting off in purchasing, working with Miss Kyle, Terry, and Angelo. I got to look at how they keep track of the vendors that we use, how they look up prices that we've had previously using the job scope system that we use here to keep our inventory, and also information about our vendors and our products and hardware that we receive here. I also went through mechanical engineering, which was with Ms. Kathy. I got to also go a little bit further into job scope and navigate through the storage spaces that they use here to find different parts manufactured and purchased as well. And also assembling products, assembling things in SolidWorks. I started to continue what Nick had started, the assembly of a machine. From there, I went to tooling engineering, working with Tim and Frank, and I actually got to measure some of the products that we had received from a company. The ones that I was measuring were pills, and they actually keep a book that shows you which sections of the pill based on the shape that you should measure. And from that shape, I went and designed with the help of Frank, designed the blister cavity, which would be used later on to design the tooling for it. And then I went to controls, which is actually where I started off when I was first hired. I worked with Jose and Robert, fixing up red lines, and then doing my first time doing an FAT, which is a factory acceptance test. But what we did there was we basically went through the PLC, which we pulled up on a computer screen, and made sure that matched the FAT, what they said that every device should say, which is the PLC, the HMI, and also the drawings themselves, making sure that they all matched. But going in and seeing those schematics and changing them and fixing the red lines, you're seeing what the people on the floor are finding problems. But going from that and going to the actual electrical side, working with John and Pat, which I was working with them for a few weeks before the program had started, just started wiring up PLCs and wiring up the panels that are the brains of our whole machines. Getting to actually see those wired up after working in controls, it kind of made it click a little bit more. So when I went back into the program and went back into controls, it all made a little bit more sense because you get both sides, and that's everyone will tell you that over and over again. All the guys on the floor, make sure you pay attention and you get this knowledge now, because when you're designing something, I won't have to stick my hand in some awkward situation to put in a bolt or something that needs to go in that my hand won't possibly fit. But I also went through the mechanical assembly with Ralph and also with Bobby. Ralph's was definitely, you got to see how much they struggle every day with parts and making sure that you have everything that you need. I had to go through a pre-assembled part and see what was missing on it, because when they had originally built it, they were still missing some parts. So I had to go hunt those down, and it turns out one of the shafts they figured out, instead of making it, they could just get it from a vendor. And so I had to go hunt that down. And then when I ended up getting all the parts that I needed, which were just long shafts, I had to start assembling it. And then when I started putting in these shafts, they stopped. They stopped not even halfway through the hole, so I had to figure out what was wrong with it. And I called Ralph over with me, and we started looking at it, and turns out there was helicoils inside of these holes. And the helicoil, which kind of looks like a spring, and it goes inside of the thread. And the helicoil was stopping the rod from going inside, stopped it from going all the way through to put a cap on the end. So I had to go take that to the engineer who originally designed it and tell him what was wrong, and he made a revision. And the next day the parts came back fixed of what was wrong. They just had to re-drill the hole, re-tap it. But the worst part about it was taking apart the helicoils, taking them out of the holes, because you had to get it right at the end and pop it up and then rip it out, and you're tearing up threads, and it's bad to look at. But after doing all of our rotations, we started to do our class projects, which we took to Bauer, and we got to go talk to so many people from different colleges, from different companies, and also important people in our county. And just getting your name out there and getting to meet those people is something that's important, because people are going to remember your face. They're going to know who you are, and it's something that no one can take away from you, is people knowing you. Some things I did love about this experience was that you're getting to work with the employees. You're getting to work with people who do this on a day-to-day basis, and you're getting their knowledge and their skills, and they'll teach you little tricks that you wouldn't have thought of if you didn't have the years and years of experience that they have. And also learning going through the MSSC, because my school actually offers it. I didn't take it last year because I was busy with my AP classes, but I did plan on taking it my senior year, so since I have the safety under my belt, get to make the program go a little bit faster for me. And I also liked going to the different parts of the company that I hadn't gone to before, even though I was here. And I hope for next year that the program is set up a little bit more organized, so that way when we go through, we're not looking for jobs to do. That always seemed to be a problem. And after, I was hoping that instead of staying for just 2 days like we did in the actual program, to stay for maybe 3 to 4, so that way we get full-on experience in each spot, and then be able, towards the end, to choose which part of the company we want to stay in and learn a little bit more. So that way it's a little bit more personalized to what we want and what we're looking to aspire for. But I do want to thank literally everyone in this company because I couldn't imagine being anywhere else but here. Because I visited so many other companies through the engineering academy. We visited so many of them, and this one really stuck. Even in my freshman year, going to other ones, this one was the one who brought it out and made it seem like they really cared.
You may not have known everything she said technically, but did you detect the level of enthusiasm? Good, good. You'll see that with all of them. There's this level of enthusiasm, I don't know, where it comes from their ability to learn and the experience that is offered to them. It's invaluable. Next, we'd like to introduce Hannah Grant.
So I started with engineering in my freshman year with the academy with Mr. Hoffman, and we had taken a tour of Paul Aerospace and Pharmaworks. And I remember going through Paul Aerospace. I did not like it. It was too big, it was too technical, it was just not for me. And so when we came to Pharmaworks, I noticed that it was a lot smaller, more family-like, and it had a better, I guess you can say, aura to it. I don't know. But I met Peter and Trevor and all of the the mentors and stuff like that through the tour, and I fell in love. And it seemed like Peter was always there after the tour, whether we had something going on with the academy or something with robotics, he was always there. And what really got me going is last year, once Amber started working here, we had the same class, and she would talk about it all the time. And I thought, wow, I would love to be a part of this. So I put in my application, I got an interview, but originally I had not gotten the internship. So, but luckily for me, someone didn't want to do it. They went and had somewhere else to be a prior opportunity, something. I'm not sure. But, so I was informed 3 days before the internship started that I got it. So I scrambled to get my stuff together, and our first week here was all safety training. Everything safety. We sat up in our classroom and went through PowerPoints and packets and stuff, how to incorporate it into the workplace. And after that, our shadowing began, which I began in the machine shop, I believe, and I already knew like stuff with the milling machines and the CNCs through the academy, so I was pretty much, because I was not 18, I was just watching and observing. So I learned about the 5-axis machine though, which is really cool, because I didn't know you could have 5, 9, multiple, more than 3. So I found that fascinating. But then I went into controls with Jose and Robert, and we were in the theater room over there, which is a controlled, no humid, it's like 69 degrees in there continuously, and we were working on a machine that took pills from a hopper and put it into a track and rejected or put it into a box to send out to packaging, which there were multiple problems with that. So we had troubleshooting. We took out the camera, the slow speed camera, to try and figure out what was wrong. And we found that there's like slots where the reject pills come down, and they were bouncing off of the plate. And instead of counting 2 pills, it would count 1, so our numbers were off. So we found that problem and hoping that it is good now. But I went to purchasing with Kyle, Terry, and Angelo, and that was a bunch of paperwork and computer stuff, and that was very interesting to see all the little stuff that went into just buying nuts and bolts and stuff to make the machines. And then after that, I went to mechanical with Kathy, and I learned how to maneuver SolidWorks, which is pretty much just like Autodesk Inventor, which we use in the academy. But I pretty much learned what the term intern work meant, because I had a lot of also paperwork, and I was organizing bookshelves and the stuff that needed to be done. And then after that, I went to assembly with Ralph, where I pretty much put together the frame of a TF1E. And I found it interesting to see Ralph and Ingo conversing, because they both have such heavy accents. It's great. I loved it. But on the assembly floor, I work with John and Pat, which do the electrical work, and they pretty much taught me the most, I feel, because I knew nothing about electrical. I didn't know that there were different type of wires for different ferrules and all this stuff. It just blew my mind. And I pretty much learned the different components of a panel board, the different wires and how and where they were used, and it was just great. I loved that. And I loved going to Bauer also, because we got to represent the company. We talked to people from other companies and told them pretty much what we did and why we love Pharmaworks, just like I'm doing now. And it was really interesting to see the real world aspect of that, like coming to life. Because we got to sit in a press conference and all of that stuff. It was really cool. But this internship as a whole has been a really great experience for me. All the mentors, the owners, and everyone really helped me to gain experience that I know I'm not going to be able to get in the academy. But some things that were not so smooth because we were in the pilot program, like sometimes we didn't have enough work, we didn't know where we were going or what to do, and a lot of the stuff towards the end was last minute. But I think just for next year, we need to get a little more organized. But I would like to thank Peter, Dan, Trevor, Michael, and all of the mentors that helped me along the way. It was definitely a great way to spend my summer.
All right. Next in line, we have Miss Sarah Sharp.
Well, as I said before, I heard about this internship from my mom. I mentioned wanting to get a summer job, and originally I was actually just thinking about working at Publix or something. I just didn't want to waste my summer sitting at my computer, so. And I originally had no idea that this internship even existed, so when she mentioned it, I was just like, what? Because I have decided recently that I do want to be an engineer. I want a career in engineering once I'm out of school, so to have an internship that would actually help me with that is awesome. This past 6 weeks, my overall experience has just been great. I've loved it. Some of my favorite parts was actually the class project. It was great to be able to put something together. And I think another cool thing about this was being able to actually see every different department and seeing how much has to go right for a machine like the ones that are made here to actually be built correctly. There are so many different aspects that have to go into it that you don't normally think about. A couple of the departments that I think I might have enjoyed the most were actually ones that I didn't get very much out of. Like the machine shop here, I'm only 16, so I didn't really get to use anything. But I think I found it really interesting, and I think I would have liked it a lot if I actually got to use them. And I know a couple of the other interns got a chance to learn more about electrical, John and Pat, and I never got to do that. So I think a thing that could be done for next year is to include electrical in the rotation. Because for example, in controls, it seemed like I probably could have benefited a lot more if I actually had some prior knowledge of the way that the electrical things are set up that I didn't actually have. So I found myself not being able to understand it some of the time. And as some of the other interns said, a lot of the time they didn't quite have enough work for us to do. I remember one day where I actually got kicked around 4 different departments that all ran out of work for me. And if I had the opportunity to do this again next year, I would definitely go for it. It's been a great experience. The 2-day rotation, I think, could be changed. Maybe 3 days would work. And I'd also like it if there might be maybe some choice in where we got to go. But overall, as I said, it's just been great. This is an experience that I just can't get in school. I don't go to an engineering academy. I go to Harbor High School. And I just like to thank Dan, Trevor, and Peter, and everyone else who made this possible. It's just been an awesome experience. Thank you.
Thank you, sir. We're getting down to the end here, except, let's see, we got Matt and Jacob yet. Matt Brower.
West Ranch High School, which is down on Wesley Chapel. But unfortunately, like some of the other schools in this area, we didn't have any engineering program, any engineering academy. So I had no prior knowledge about SolidWorks, about how this machine operates, you know. I had aspirations to being an engineer, but I had no clue in what field. But as luck would have it, my dad happened to be one of the owners of this company. So I've been around this company for most of my life. When they bought this building, I was in here pressure washing floors, you know, just doing the dirty work. And I was really excited to finally get in the infrastructure of the company and realize and learn how it really works. You know, because if someone asks, like, what does your dad do? It's kind of hard to explain this whole process without knowing how it comes together. And when this internship first started out, we were in the classroom. We were doing MSSC training and PMI. You know, I was kind of like, oh, great. I just graduated. Now we're going to have to sit in the classroom. But after that first week got out of the way, we were able to get in the floor and start doing some physical things. And I took so much away from each department. You know, I thought I had an idea of what was going on here, but I learned so much. It was incredible. I'll start off with Bob over here. I was in inspection, and I was learning how to use calipers and micrometers and how to read prints. I didn't realize that they had to inspect every single little piece, whether it be from the vendor or from a machine shop, and how important it was that everything was correct. Because if it was in the machine and was already in assembly and didn't work, it had to come back, you know, that's time and money. So I saw how important this department really was. And it was funny because sometimes I'd ask Bob how you measure something, and he'd explain it, and he'd be like, well, we don't have that piece of equipment here, so this is how you do it. So it's really neat to get some of that tribal knowledge and how to troubleshoot problems. Another department, I was in mechanical engineering with Miss Kathy. Like I said, I had no SolidWorks knowledge with me, so I was able to run through some tutorials and get some basic background with that software, which no other kid would be able to do if they were in an engineering program or in an internship like this. So it was really neat to learn to use that high-level software and carry that with me in the future. And one of my favorite departments I worked in was the machine shop over here, because I really came into this wanting to get some hands-on experience and learn how to run these awesome CNC machines and NC machines and lathes and everything. And so I got to run the CNC quite often, and I got to learn what makes a good chip when you're milling something. You know, how long the chip should be, what color it should be, whether it be Lexan, steel, plastic, and it was a great experience. And finally, I was over in assembly, learned some tribal knowledge again, like what bolts to use, what screws to use. I was working with Ralph, and I learned a lesson in Loctite, which is like a glue. I learned that if you put too much on a screw, it can crack the Lexan. So, you know, I was kind of upset about that because I felt like I had a certain pride invested, you know, in what I was doing. But then we came over here, and Ralph and I were fixing a door, and Ralph ended up sawing the door in half. So I felt a little bit better about myself. It wasn't just me that made mistakes. I also was in controls with Jose, and you know, he was like, all right, go wire this. And I was like, I don't know what I'm doing. I guess he had expected that I had some prior knowledge on electrical. So I had to suck up my pride and taught some. It was really neat because learned how to, I got to wire a button in the machine. And so finally, we went to Bauer. And I got a lot out of Bauer. It was definitely one of my favorite experiences here because we got to go out and present, interact with people. You were part of the company. You get to show how proud you are. You know, you get to show what you've done, and you know, that was great because I feel like I belonged, and you know, I had pride in what I was doing. And some of the things I enjoyed about this company, again, like I said, we're getting the hands-on experience. You know, there's no other kid in this area gets to run, you know, $100,000 machines like that, and learn how to program things with 5 axes that are turning like this. And it's so awesome. And one of the things I really wanted to do that we didn't do was weld. I really wanted to weld, and we were supposed to switch with Bauer, but that didn't work out. So hopefully I can come back here in the future and finally get some hands-on welding. Another thing, a suggestion would be to be 18, so you can work in this machine shop. I know all the men have got to work in it. We're all 18. Cough, cough. But I know we all enjoyed it. As Jacob said, or Will say, and Nick said, and Sarah wanted to be in here. But I think it's really important to get this hands-on experience so when you're in textbooks in college, you know what you're actually doing. And finally, you know, to close, I would like to thank all the mentors, all the Bobbies over there, you know, Jose and Bob, because they're just willing to show you so much, and you just got to take it all in because it's so important to go in the engineering field. Like reiterated 100 times, you need the practical experience, and without an engineering program, this is just, I can't say enough, great experience. So thank you for your time, and Jacob's coming up next.
Her house because she was tired of having to clean the floors, and she thought that it was a joke, and me being a little 8-year-old kid, I took it seriously. And one day, you know, I picked up an NXT bot and a couple of Lego bricks, and I decided I was gonna try and build a robot. Now it doesn't work perfectly, and I don't know, it might run off the table with the tablecloth on there. That happened a couple days ago. But it got me interested in engineering, and I got to see, that's what got my drive going. And from there, I built a couple other things. I saw, I just thought it was interesting that we were working on outfeed conveyors. And when I was in my garage, I saw I had built this little, and look at that, let's see, there we go. It's a little conveyor belt made out of Legos. And I just thought it was cool because we were working on outfeed conveyors, and I had built this 8 or 9 years ago with no, practical knowledge about how it could be used in a real life business. And then there we go, building an outfeed conveyor for Pharmaworks. Today we were supposed to fill out what we did, what we learned, what we just observed, different things, so that we could come back and hopefully present our information at the end. And he kept us going, asking us questions, even if all of us were in the room, staring at each other blankly. He'd keep the conversation going, making sure that we were talking about the experiences that we had that day. Trevor came in, he came in a couple of different times to teach us about different programs that they run at Pharmaworks using job scope and how the company runs from a technical standpoint. And then all the different mentors. You guys have been so helpful. Bobby, Nick, especially, so many of these guys, Joey, you've all just gone around and answered all the questions we have, and even when we don't have questions, you explain what you're doing, and if we're just standing there, not acting like we don't know what to do, you'll come over and you'll say, hey, why don't you come work on this with me? Even if I wasn't assigned to Bobby, one day I was working over in tooling with Nick, and Bobby just came to walk by by and was chatting for a couple minutes, said, hey, you want to come learn how to weld? And so that was something I'll get to here, but I actually got to experience welding, which was awesome. So anyways, just thank you to all the mentors and everyone that's involved in the company. It's you guys are so helpful. So the very first week, the other interns talked about it. Basically, we were up in a classroom, hunkered away from all the workers out here, and went through quite a bit of different training processes. Went through manufacturing, production, PMMI, which was basically they showed us different types of gears and levers and pulleys and how that worked from a technical level. You know, their definitions, what they were supposed to do. But we couldn't get a physical aspect of it, and that's what we got out here on the machine floor. You know, what type of screws to use, which type of holes, what different types of motors are compared, like a servo motor compared to a cam and gear motor, you know, something electrical versus something physical on the motor side standpoint. We learned about the Kanban process, which was the Japanese system for replenishing overstock parts. The introduction to job scope, and one thing I didn't see. Anyways, we got towards the factory, you know, the very first week, got taken around, got to meet a couple of the different mentors, and given an idea of what we were going to be doing for the next 5 weeks. One physical hands-on aspect that we got the very first week was transporting a TF2 machine from inside the building to outside where a tractor trailer was going to come and pick it up. But it's crazy the little details that they have to put into this company. You know, you wouldn't think as soon as you have the machine built, you can't just, you know, pick it up and manpower it into the truck. They have to have this process built where they have all these different air pistons, and you have to have different pressures on the different air pistons because the TF2, you know, it's not uniform weight all across. So it was a real cool experience just moving a machine. Then for the rest of the weeks we did shadow training and went through each of these different departments. The very first one we all went through was inspection with Bob Vick here, and we got to learn what a caliper was, what a micrometer was. I don't know if you guys even know, because I had no clue what those things were. You know, I had to repeatedly ask him, what was that tool called? What did you use there? And we used gauge blocks, pin sets, and he showed what each of those things did. And sometimes he had to, you know, create his own way of inspecting because he didn't have the specific tool that you know, did a really specific job. But he came up with his own way of troubleshooting, like Matt said earlier. After that, I went over to the controls department with Jose and Joey, and they showed me how to use AutoCAD programming. And I had never even seen AutoCAD before, but they showed me some tips and tricks on what to do with wiring and how to get that on a spreadsheet. They took me, you know, into a feeder room to show me how the feeder testing went with those AutoCAD diagrams that we drew up. You know, one day what they had me start out doing was red lines, which is corrections for wiring that wasn't put in right the first time. You know, they got out to the machine floor, and the guys on the machine floor said, no, this isn't right. This, you know, this needs to be changed back in the programming. So, you know, they have the interns do the easy, you know, move the wire from that section to this section. And then after that, they gave me a blank page of an AutoCAD and said, copy it. And I was completely lost. You know, I didn't know where any of the parts were, how to set everything up, but they've helped me through it. So they're amazing with teaching. Tooling department with Nick and Mike, you know, they taught me so much, not just about tooling. What they normally do over there is they'll take a building instruction for a part, and they'll be putting these outfeed conveyors together and all sorts of things, you know, different tools. But they took me around, and you know, that's when I learned how to do weld. I learned how to build kits. That's where I learned how to read different drawings. I used a sandblaster. I mean, just saying the word sandblaster, that was amazing. It was fun to use. Nick took me around. He showed me all the different parts of a transformer. I'm sorry. They showed me all the different parts involved in a thermoformer, from the die cut to you know, the perforator to the outfeed conveyor, just everything that having to do with the thermoformer. And it was real cool how much time they put into the interns and how much they really care. Something that a quote, I guess you could say, that I picked up from him is he said, work hard, think, and observe the small things. And there were countless times out on the floor when there would be a problem or a trouble, and Nick would lean over to me and say, you know, it's probably it's a circuit breaker. And, you know, they'd be over there on the thing trying to figure out why the machine isn't running, and they'd, you know, run around the back, and of course the circuit breaker would have just flipped. And, you know, it's just crazy that just observing the small things can fix so much. And that was something I really took from that, and I'm going to go forward, you know, throughout life, just look at the small things. Mechanical engineering with Kathy Schaff, she showed me different parts and how they put together all the different aspects of a machine. Tooling engineering, that was up in, I just learned the background to what makes a thermoformer, not just the machining aspect or putting it together, but how they come up with the parts, how they design the parts. That was real interesting. Then down in the machine shop, and the first time when I was through the machine shop was before I was 18. So actually I was standing back and I was observing, but I got to learn so much just from the mentors teaching and saying, on a lathe, which direction you have to go first, and making sure you leave room to give yourself a finished cut. And by the time I got back there for the second time, this was the only station I got to stay for I was there 5 days. And so by the end of the third, fourth, and fifth day, they were letting me go onto the CNC machines, and I was running parts practically by myself because I had been there for long enough to get an understanding of that department. And that's one of the things I would look forward to, and a change maybe to the internship program is to have certain areas that if you're interested in it, you could stick around that area for 3 or 4 days. So you know what you're doing there, and you can, instead of being trained, you can start working towards productive things, and actually, working instead of just learning. And it was really cool to do that in the machine shop. Finally, over in assembly, Ralph and Bobby, they were running around helping, not even on their own projects, but if something was, a hot project and needed to be done, and a day or two later, they would drop what they were doing and help out the other guy right off the bat. And that was real cool, seeing how well everyone over there worked together, and just putting the machines together. There's some different tips and tools, and like Matt was talking about, trivial knowledge. Sometimes the tools won't be available, and you have to figure out how to make the part fit, even if it wasn't designed to fit in the slot, like a cover. We had to take off some lengths to a cover so it would fit on the machine properly. Stuff that we did, the shadow training, it was really nice. A couple of things we went through were class projects. We went from building shelves, we cleared work areas. We worked on a Kanban sticker project where we basically took you'll see buckets around that were full of screws and washers and things, and we ended up going through doing some intern work. But working together, we built up that communication, how to work with other people. This area behind the storage, or behind the curtains, we actually organized it and worked on that a couple days before today. And just working with each other. It was really nice experience learning what to do, how to work efficiently with others. The Brower trip was really cool, being able to show off what we learned here at Pharmaworks and being able to talk to other companies, see what they were doing. Some companies, all they had were CNC machines, and they didn't have the paperwork and the purchasing. I think I skipped over that, but purchasing, that was a real cool aspect of this internship, is being able to go to every different job, not just down at the machine shop and with engineering, but I went to the purchasing side, which isn't something I would want to work on, probably not as a future job. I don't see myself sitting in front of a computer, researching parts and prices and things like that. But it was cool to get that overall rounded experience. In the Brower trip, we got to see that, how different companies work. Some crazy learning experiences. Every day here I was learning something new. I learned how a manufacturing company works, working in all those different areas. I learned how to operate a mill, a grinder, welding, sanding, just everything that you have to do to a part. Working with CNCs, purchasing orders, AutoCAD programs, job scope. Over in tooling, I learned how to set a pressure nut with a drill press and some, not calipers, a drill press and a reader. I used a sandblaster. It's just being able to figure out how to learn and operate all this different machinery you could never get from a textbook or from an academy, or I could go to college for 4 years and I still wouldn't know how to use a sandblaster. You actually have to be there and get some real world experience. So that was really good learning experiences. New vocab terms. I learned so many different terminology. Sitting out on the factory floor, people would be talking about the bill of materials, and we have an FAT coming up, and I was having to question, what are you talking about? What's an FAT? And by the end of the internship, I could speak engineering with these people. It wasn't like speaking Spanish to them anymore. I was actually understanding what they were talking about. And that was real cool, just learning how to talk to someone on the factory floor. There are so many things I love about the internship. You know, getting to every department, I think that's something amazing that should be kept in future programs if it's run again. The mentors were amazing and helpful and answered any questions I had. Another really cool thing I liked about the internship was gaining that MSSC certification. It'll not only help us stay safe when we're here, but it's something we can use in future jobs if we come back to Pharmaworks or if we go somewhere else. We can say we have the safety certification. You know, you can put us on the floor right away. Instead of them having to put us through more safety classes, we can start right on the floor again no matter where we go. Also, I think it was really cool getting the safety training out right off the bat. So instead of going back, you know, once a week or, you know, later in the day and midday, we got it all. A couple of different things I think could be opportunities for changes in the future would to either lengthen the entire internship and make it so each department you went to, you know, you had 4 or 5 days, so you could get to that part of working on your own without having to ask your mentor all the questions. Obviously, you know, you'll still be learning from them every day, but I felt like when we were at certain departments, when we were only there for 1 or 2 days, by the end of the second day, I was getting to the point where I could do things on my own and work on my own, but then I moved on to a different department. So maybe picking out certain departments that you know you'll want to work at, like the machine shop or assembly. Maybe you want to work in controls and pick out 1 or 2 of those different departments and say those are the departments I want to work on 4 or 5 days. I mean, I don't think most people want to work purchasing 4 to 5 days. I don't think I could take that much paperwork. But if you want to pick, I don't know how you guys do it, it's impressive. But if you want to pick out the different places where you would want to work out 4 to 5 days, maybe make the internship a week longer so you could do that. I wouldn't want to sacrifice missing out on working in purchasing. It's good to get that background knowledge. But to get those 4 to 5 days to work like I was in the end of the machine shop, I was working on parts all by myself. If I could have done that with tooling and putting kits together by myself, we got to that by the time we were working as a group, because we were working as a group on the project for about 3 to 4 days. But just getting that 4 days in, that would be really nice. Another thing is I think Matt and I both covered this, is incorporating a welding segment. That would be really cool, because I had such a great experience learning how to weld. I think it was only maybe 30 minutes or an hour, but getting that experience on what welding is and just basic things like you have to use a filler when you're welding. I didn't know that. I thought it was a blowtorch putting 2 pieces of metal together. Sometimes you have to take a filler, which is an additional metal, to blend them. And if you touch the welder to the metal, then it's going to get stuck there, and you have to go and grind the tip down so you can use it again. And just learning how to weld, just observing it would be a real cool experience. And I think that would be something awesome for future interns. And I remember Sarah said earlier, working in the electrical department on the floor, that would be something really cool too, because I didn't get to experience that either. And I think that would be a good addition, is the floor electrical part, not just the controls. Anyways, and closing, thanks to everybody. It was a good experience. I learned so much from working here, and just not even on an engineering standpoint, but people help me figure out what do I want to do as far as engineering goes. I don't know if I'm going to be a mechanical engineer or for a chemical engineer, or maybe a math teacher, I'm not really sure. But being here, it's shown me what a manufacturing company is like and how that connects to engineering. And you guys have just been so helpful, and the program was set up really well. Thank you very much.
6-week period. But I just wrote down 1 or 2 things that I just wanted to share with people, and thoughts that I had as I was listening to them. One is that robotics programs are important. They're important for kids in school that have got an interest in going to engineering or into manufacturing. And if kids show an inclination in that direction, getting them involved in robotics is a great first start. The other thing that I heard both ways, one from a positive perspective and the other from it was missing, is engineering academies. And those children that have come out of school and gone into engineering academies and come into internships, they've been so well prepared to come into industry for some hands-on experience. And the guys that joined us that hadn't had that experience, they were a step behind, and they've had to play catch-up during that period. So that is important. just generally that hands-on experience and that opportunity to see the big picture and not just hands-on on a particular machine, but I think they've learned as much out of seeing how an organization works and how everybody needs to work together as a team to make it all come together. At the end of the day, there's 92 people in this organization, and we're really all focused on one thing, and that's building and selling machines. It doesn't matter what part of the machine you're involved with, whether it's cutting invoices or purchasing or HR, we're all focused on the same objective. Because unless we're building and selling those machines, none of us have got a job. So seeing how that all fits together is really important. We had a lot of offers from the interns for improvement, and we did ask for that. We consciously said to them, you know, what did you like about it? What didn't you like about it? How could we improve it? And certainly you've made some good suggestions, and we will be thinking about those as we go into next year. And certainly some of the areas you talked about, we'll think about whether we can incorporate those. Although we do have our hands tied with age 18 being a threshold. But you know, we'll try and do what we can where we can do that. What I'd like to do now, and then after we've done this, we'll open it up for questions, because I know one or two of you have got tight schedules. We're going to present certificates, and then we're going to open it up for a Q&A. I'm going to ask one of the owners, Ingo Fidel, if he'll join us. He's going to present the certificates. Ingo is a product of the engineering training that we talked about earlier, and he's the driving force from a technical perspective within the organization. So I'd like to introduce Ingo. I'd like to present the certificates of completion to the interns, and we've also got a card for each of them, so I'll ask them if they'll come up to receive their certificate from Ingo. So Amber, if you'd like to come up first. And secondly, Hannah. Jacob Dixon. Matthew Brower. I should know that, shouldn't I? Nick Harmon. And alphabetically last, Sarah Sharp. I'm also going to ask Ingo if he'll present this card from all of us to Dan. Dan interns here, so feel free to fire questions at all of them or individuals.
I'm just wondering if they could briefly go down and tell us what their plans are now that they're finished with their internship for the fall and go down the line real quick. Well, for me, next year I'm going into 11th grade and I'm actually in the IB program, so yeah.
I just graduated from like high school. I'm planning to attend the USF this fall.
USF?
Yeah.
I'll be going to the University of Florida in the fall for aerospace and mechanics.
Creators. I'll be going to the University of Florida in the fall as well, hopefully for chemical engineering, maybe a major in that.
I will be finishing my last high school year at River Ridge in the Academy in Eastern Mountain. I will still be working here over the summer and also during the school year once I get my schedule and figure out where I'll be, when I'll be able to come in, and then after my senior year, hopefully going to UCF.
Is the 2013 summer interns would like to thank the company for the opportunity you've given us. We greatly appreciate the time and resources spent on our behalf. Working at Pharmaworks has been a unique experience in which few people get the chance to participate, especially amongst our age group. As aspiring engineers, the hands-on experience in the manufacturing environment has provided us with knowledge that cannot be taught in the classroom. During the course of this internship, we were able to obtain an MSSC Safety Awareness Training and Certification courtesy of the company. This newfound sense of awareness and skills has opened our minds to potential hazards in industrial situations. We can also utilize the certification in our portfolios for future reference. We'd like to thank the mentors that offered us guidance throughout this internship. They've been insightful and helpful. Not only did they share their experiences, they readily answered any questions that arose. These mentorships offered us several learning opportunities, including programming a CNC machine, deburring and sanding, navigation of SolidWorks, and the assembly of an outfeed conveyor. The internship has taught us how an engineering firm operates on a day-to-day basis, and the structure has enlightened us as to how a business functions in the real world. We were surprised at how many departments it takes to run a successful manufacturing company. By rotating through the different departments from purchasing to mechanical engineering, we were able to see firsthand how the various areas rely on each other. As the pilot group of Pharmaworks internship program, we'd like to thank Pharmaworks for investing in us. We believe that future interns could benefit from the program just as much as we have. This has been a very rewarding experience, and we're sad to see it come to an end. Based on our experience, we would like to see the internship continue and prosper after our departure. Many thanks for this adventure. I think, from a company perspective, that makes it all worthwhile. And we really would like to thank those of you from the county, from the schools, from the workforce board, from CTEF who had to step out, for the support they've given, from the investment we've had, and we think it's been a great success, and I think what you've heard, you can't help but agree with that. We're definitely going to continue this, and Ingo's hope, my hope is that 5 years down the road, recruitment's going to be a damn sight easier than it is today. Thank you very much. Good job.